switched over. You guys should now be seeing a big infographic, which I will be sharing along with links and other things after the meeting. So this is what we're up to. There's a lot here. Give me a couple hours. If you have to leave early, that's fine. But try to hang with it if you can, if you have the time and the energy. But this is a big smattering of what we're up to. And so it's comprehensive. I won't cover everything, but I tried to get the basic scenario and then some of the finer points. So over on the left, we see a bunch of basic things about how sheet metal works, the physics of it and whatnot, things about the bending and the reliefs. Here we have a unfolded for putting a feature across a bend. Here is a DXF that we get out. There's a flat pattern. And here are various examples, and this file will be provided to you as well. But as we start, I want you to go from scratch and not be referring to that. Here we should be looking at the announcement that I put up, which has the links to the material that I'm going to be showing. Mine's a little bit updated. So these are live links on Google Drive. So you'll want to go afterwards, maybe when I let you know, and download it again. These are live documents. They'll have the most recent. And then that is all we have to see in there. Here's everybody who showed interest. So I keep track of who made it. All right. So I have an overview document and a topics document. So we're going to go into the overview a little bit here, and I'm going to brief over some of it because most of what we are going to do is discover things in the moment as we go through the lesson. So I'm trying to get, so I want to get into the meat of the matter and the interactive activities. But if you can mute John when you have interactions on your side, that helps. Thanks. So thanks. So
she brought me soup, sorry.
Oh, good. Enjoy.
I'll try not to disturb the class again.
Did she make enough for everybody?
Virtually, yes.
Okay, good. Everybody, bon appetit.
Yeah, right.
Buen provecho. Okay, so I'm going to go into the overview here and gloss over some of it, but just give you an overview and a exposure to what's coming. And then I have my topics document, which is kind of my cheat sheet of how things are going to go progressing in time from one thing to the next. So anyhow, let us take a quick look here. And I will note a couple of things. I'm very philosophical in my approach to things, how I consider it often more important how you think than what you think. And that's why this presentation class is going to be concept focused and not point and click. Point and click is good, it gets you places, but if you don't have the exact thing, or they change the names or the interface or something is different, you're stuck if you're just learning point and click. So if you understand conceptually what's up, then you can solve all your problems and you won't get stuck as often. But that's really a big major difference as to how this is going to go down and hopefully how it will be better than other approaches. As far as learning, I say everything I learned I didn't know before. And also confusion when learning is normal, so embrace it. We all know that state, but we look back on it and we get the aha moment and everything looks simple and clear in hindsight. So keep a positive attitude as you go and you will be more effective. Anyhow, so there it is. We're going to go over the sheet metal creation, both in the sheet metal and by other means. Sometimes that's necessary. Here's all the stuff about getting onto the Zoom. We don't have to worry about that. So the focus on concept, I make a comparison and connection between concept and concrete. Concept is the idea. Concrete is the implementation of that idea or the names we give to the idea. So if you have the concept worked out up front, then you can decide from the multiple possible implementations which to do, how to do it. So that's really the essence of this philosophy of concept and concrete together. Then the lesson plan, in the meat of it, I do something and then you repeat it and then you ask questions and we share screens back and forth if we have to clarify. And that's how that's all going to work. So here we get into some of the details and some stuff I have to fill in yet, like keywords at the end for you to review after the class. So that is that basic intro there. So now we're on to the topics sheet. There's a section here with some specifics that I will brief over. And again, we're going to be encountering these things and learning them by doing in the moment. And then there's my setup for millimeters. So maybe Dean, who came in late, make sure your fusion for this particular file document is going to be in millimeters. We got an activities list, and then we have details on those activities. I'll do this briefly before I do the specifics. It's quicker, easier. So here is the flow of things. Many different kinds of flanges and many different things we can do on those flanges. A face flange, we can bend, edge flange, contour, lofted flange, all kinds of flanges. Our flat pattern in our DXF. We have a special case where the standard isn't appropriate. We have to do it in a different way and then make it a sheet metal. We're going to talk about the 2D drawings, official with a title block and everything, not a sketch. Remember, 3D CAD is different. A sketch in 3D CAD is not a 2D drawing traditionally. They're different things, different purposes. I will be introducing and focusing on terminology when it's important to be clear and to make distinction. My job is to understand what you mean and not what you say. Sometimes you're using terms incorrectly or non-standard, or you just don't know how to express it. So in context, I have to suss out what you mean and not just what you say. But to the extent that we have a shared language, shared terminology, we'll be more efficient, effective, and productive in our communication. So that's the value of attention to language, the words we use and whatnot. So the 2D drawing, sending out a DXF and having it programmed on some other machine somewhere else. And also you can program right in Fusion in the manufacturer workspace. So there's several ways that once you get your model, that you can generate the data to control your machine with your machine control code, G code sometimes referred to. All right, so that's all good. That's a little preview of where we're going with our actual activities. So here is a long list of stuff that you can go back over. I'm not going to belabor too much on it, but you'll have it for reference. So this is a lot of specifics as far as a sheet metal component versus a standard component. What you can and can't do in sheet metal. It's basically for basic bending with a press machine. So you cannot do things that are like die and punch where you're deforming the material in ways other than simple bending. There are things that it doesn't support natively, but you can still do, like making a hem on an edge where you fold it over, or strength, rigidity, and or handling and appearance. So you can make hems. It's just not natively supported, but there are ways you can make it work. So just know that you're not going to be able to model every sheet metal possibility. It's a very broad and deep manufacturing realm. And you might be able to make something in a model that you can't produce in the real world because you can't fit it into the fingers of your press brake or something. So you have to take into consideration quite a number of things to get out what you're after. There is a rule for your sheet metal design, and these are going to make things conform to the real world. For instance, constant thickness everywhere. So when you have your bends, the radiuses, inner and outer, have to be in such a way that you get a constant thickness through that bend. And our sheet metal mode is going to ensure those things. But if we do it in solid modeling first and convert, then we can use the sheet metal mode. And then we can use the sheet metal mode. So we have to pay close attention to ensure that we're conforming to reality so that we can actually manufacture the thing. We have some other aspects, unfolding and refolding, as well as flat pattern. We'll get into those and how they're similar and how they're different. We have different datums references to determine how our bends are happening and what the final result is going to be. Like we might want to have the face to face a certain distance. So we have to pay attention to things to get that to work the way we want it. Here's the DXF output. We're going to talk about that. Here are our flange types that I've already gone through: face, edge, contour, and lofted. This one relatively recently added, which is nice to automate things for us. And then we're into here, and I think that is, oh yeah, this last little interesting part. You can use the sheet metal to actually do paper and cardboard folding. So if you have cartons, containers, boxes for audio equipment that has weird shapes or something like that other than a standard box, you can just change the rule and make things that unfold. So the whole idea, by the way, with this is to have an unfolded thing, flat plate of metal in most cases, and then you cut it out and then you fold it up into the shape. So we might call that a developed surface. That would be the fancy terminology. It's developable. And in math, they call it a net. Imagine a cube, how many different ways you can unfold the faces of a cube so that you can fold it back together. There are 11, by the way, for a cube that are valid. But that's the whole idea behind our sheet metal thing, is we're trying to find the net, the unfolded thing, such that when we fold it, it becomes the 3D shape that we want. So that's a fundamental thing to keep in mind. So if I look here, we went through that, we went that, and we are here. And let me move some stuff out of the way. So this file is going to be for reference while we're going here, and I will share it ultimately. But you can see, as we have previewed, we have our face one there, and then we have our edge flange. Then across a bend, we're putting a feature. There's our contour, just a simple open profile. There's our lofted one at the bottom there. And the last is a special case where we have to do it as a solid first. It just doesn't lend itself to the sheet metal mode. These last two, I may be more showing unless you're interacting. They require a bit more setup in sketching and whatnot. This one, not as much in some aspects. And we'll determine as we go as far as time allotment as to how deep we're going to go into these last two. So they will at least be exposure so that you can see a broader range of things in here or that relate to sheet metal. All right, then everybody should have a new file up. So I am going to do the same and say Control S command. Oh, that's safe. Control N, Shift N. That gives me a new tab. And I have here, and by way of review, here I am in millimeters. So if you haven't done so, get yourself into millimeters like that. And let me hide some zoom. You won't see my zoom stuff, but every now and then it gets in my way. Every now and then your zoom interface will get in your way. If I'm referring to something and you don't see it, it might be behind a zoom window, and just move stuff around as needed. All right. So we are going to, by the way, preferences. Everybody has different preferences. Let's try and cut this off at the pass. Go up into your preferences in the top right where you see your initials or your avatar. And that's where we get to our preferences. And let us come up in the left where we have general. We're going to go into the design area of our preferences. And I want us to turn off in the center, auto hide sketch on feature creation right there. Auto hide sketch. That one is on by default and confuses people because they make a sketch, they apply an extrude or something, and it automatically turns the visibility off for the sketch. And the user says in bewilderment, where did my sketch go? My sketch disappeared. It's trying to help you, but not in all cases do you want it to do that. So I like to decide if, when, and what happens in most cases. So go ahead and turn that one off. And that's probably good for the rest of it there. So hit enter on your keyboard, and that will accept the changes. You don't have to click your mouse anywhere. All right. So hopefully we cut that one off at the pass and the units. I think if we find something along the way, I'll just have to address it. All right. We are going to be making components. If you don't already use them, I highly recommend you do. They are containers. Component is simply a container for things. On your tree on the left here at the top, the root, every file starts with a component indicated by the white cuboid. And so this contains these things and forces certain things here that get made. So I make a separate component, even if it's just a single part, so that I compartmentalize everything into that component. There are other good things about components we can discover along the way. And so there's not a hotkey. Let's make a hotkey because we're going to be doing this multiple times. So up here under the create menu, the very first item is new component. And if you hover over it, there are 3 dots. You're going to click on these 3 dots, which is a menu. And you're going to go to the last one there for shortcuts. Go ahead and activate the first field here. Hold the shift key on your keyboard and then click the C, and it should populate it with shift C for new component. And if all goes well there, you just hit enter. And we'll confirm, and slow me down if you have to. I'm kind of moving along here, but trying to keep a little time in between. So if you have done all that correctly, let's confirm. I always do a sanity check often to make sure that things do what I think they were doing as I think I understood them. So now you should see under new component, your hotkey combination called out as shift C. So I'm going to click away. So now we are going to do that, shift C, and we're going to take a look here and notice that it says likely the type is standard. If we open this, we also have sheet metal. So the beginning ones, we're going to want sheet metal. We have it in this default of standard or set to standard because we are in the solid tab in the upper left here. So these are our context tabs. What context are we in? Because we are in the solid by default, when you start a new file, it is picking standard. So you can change it here if you want to or need to, but we're going to cancel. And now up here in these tabs, go over a few, and we're going to click on the sheet metal tab. And now you see the toolbar is changed. Now the tools relate to the sheet metal context, and some are common between our different tabs, etc. But anyhow, we should now be in the sheet metal mode context. So now when we do shift C, go ahead and do your shift C, and the type has automatically been set to sheet metal, which is what we want. And it has chosen a rule. Let us make sure that we all have the same default rule of steel metal. You can create some. My list is longer, but the default here is steel millimeters. Assuming that you all have that, we'll hit enter, and it becomes the active component. There was a checkbox there. By default, it's active. This is crucial. New stuff goes into this container. And if you get a lot going on and you don't pay attention, stuff goes where you don't want it, and you might have some issues correcting it. So try not to make that problem in the first place. So we now have our sheet metal component, and you notice its icon is different, indicating sheet metal component. And this has gone from one box to multiple boxes because we have multiple components inside that one. So pay attention to the icons, their shape and their color, and they're going to tell us important things. Rule 1 is save early, save often. So go ahead and hit Control or Command S, and then hit enter. You don't have to move your mouse. There's an active button in every dialog box generally. So the less you move your mouse, the faster you're going to go. And so now we should look up in the tab up at the top here. And mine says Untitled V1. You could give it a logical name, sheet metal class, whatever you want. I just went with the default. This is a recent file. If it has a star, a little asterisk, that means unsaved changes. So pay attention. Save often as you don't want to lose what you've done. It's being stored up on the cloud somewhere, not on your local machine. So you're not incurring any cost in that way. And it's unlimited. So I save more often than most people probably. Anyhow, there's the good news. We have gotten a lot of the basics out and we have our component ready to accept something. So we first are going to do our simple bend based on some lines in a sketch. So we're going to make a rectangle and whatnot. So hit R for rectangle. And it's now asking us, let me make sure this, while I'm doing it, look in the upper right on your view cube. Make sure you are Z up. That blue Z axis is pointing up. If anybody has anything other than that, let me know now. Y up is another convention that works, but in this case, and in a lot of cases, Z up is nice to have. All right, so everybody is in Z up, and the tool is waiting, if we still have it, to make our rectangle, saying where do you want to put it? Let's go to the ground plane. That's our XY, our red-green axes right there. Click that. It automatically takes us into the sketch mode. Over here are the types of rectangles in our sketch palette on the right here. I'm going to choose the center one, center rectangle. Let's go ahead and hover over the center point. It'll lock into there. So click on it, let go, drag, glide out. It's waiting for us to enter one of the dimensions. We'll call it the depth, and it's waiting to type. So this one, we're going to make 50. And hit tab, and that's going to take us to the next dimension, which is our length in the horizontal. We're going to want to put some math in here, so go ahead and put 100 plus 2 times 2, shift 8 is our times, and that 50 that we're going to go on each side actually. So I have just put in 100 plus 2 times 50, and I hit enter. And that result is 200, because we're going to make a 50 line here and over here to do our bends. So 2 50s on each side is 100, and in the middle is 100 more. That gets us our 200. So 3D CAD is nice. You can build in these relations between things, and you can come up with math expressions. The math itself is elementary in general, plus, minus, multiply, divide. The tricky part is finding out the right math. That's the part that you have to pay attention to, that more thinking. All right, so we're going to make a line on the right side here, maybe L for line. If you hover over the top line, it will find it with a little blue X somewhere over here. If you click, it'll lock onto it. Come straight down till you find the bottom line. You'll see a little blue square there for perpendicular, and click again. You still have the tool, hit enter to get rid of that. So now we're back to the picker, and we have our line, and it's constrained to the lines of the rectangle, but it can still move left and right. We need to lock that down. So click away. I don't want to have anything selected. We're going to do D for dimension, and we're going to go from that blue unconstrained line to that black constrained line on the right, and glide down. Click there and let go, and enter 50. 50, enter. There we go. And in order to get it on the other side, because we're going to bend it along that line on each side, we're going to do a mirror, and we're going to do it about the axis. So we need to make that axis visible. Come over to the tree on the left, open up your component, expand it there. There is a sketch folder there where our sketch 1 is, but we want to activate the coordinate system folder right there called origin. Hit that eyeball. We want access to that line right there, that y-axis. So if we still have our dimension tool, we don't want that. We want to come up and get our mirror tool. There we go. It's like you pick up a hammer, you start hammering. If you want to do something else, you got to put down the hammer and go grab something else. So pay attention to that. Otherwise, it'll do things you don't want it to do. So it's telling me to select the object. It's going to be this line that we made. So the blue button is always the active one. And if you hover, it'll tell you what it wants you to do. So go ahead and click that line. You could click more than one thing. So we need to come back to the dialog box here and get this select button for the mirror line. And that's why we made this one available to us, the green one. Click that and hit enter. And now we have a mirror symmetry icon here. If I click it in the lower right, there's a data info area people miss sometimes. That's telling me what I have selected. So that's all good. Go ahead and save, Control S, enter. And we are going to go back to our tree and hide our coordinate system. We don't need that anymore. That was just temporary. And that's all good, good, good. We are done. And it's fully constrained, by the way, with the little red lock, right? When you start, when you're going, you have a pencil, an edit pencil. So in addition to these lines changing color to indicate that they're getting locked down, when everything is fully constrained, which is in general a good thing, you get a red lock to let us know that that's done that. All right, we're going to finish our sketch. And it came to a home view for me. That's fine. So we're going to make a flange, and we're going to make it all the way across all three of those shapes. So there is an icon for it up here in the upper left in your toolbar. There is the flange. So click that one. And we're just going to go to each one of these closed profiles. 1, 2, 3. And you see it has extruded it up by the thickness according to our rule. I missed one there. There we go. Make sure that you have all three, and they'll be showing here in your list, and they'll be showing here on the button, 3 selected. So that's our sanity check, and visually also. So we have all three of those have been extruded up. Our bend line has to be on the surface that we're bending, so let's make that go down, and that we do over on the right here under operations. From side 1, we're going to go to side 2, or center in other cases, but side 2. And if you look carefully, now your extrude has gone down so that our bend line is on the top surface where we want it. That's the whole reason for that. So go ahead and hit enter. And you will see over in your tree on the left here again, a folder has been created for the bodies. And that little icon tells us that it is a sheet metal body. Again, paying attention to what the system is telling us. So now we're going to do our bend. I know where it is, but let's pretend we don't. Hit S for search. And right where your cursor is comes up a search box waiting for you to type in. It's context sensitive for this mode, this context. So I start to type bend. There's only one that shows up. I hit enter. There we go. So now it is asking us to choose a stationary face. It's going to be this face here. Well, it's all the way across. So go ahead and click that one. And we're going to leave everything as is. Hit enter. We need to be doing something else, don't we? We need to select our bends. So click that line that we made. And click that other line that we made. And now hit enter. Now our OK button is active. I was premature. And save. Control S, enter. All right. So we have accomplished probably the most basic thing in sheet metal. And we're keeping this simple, by the way, on purpose because we want to find the underlying system and the relationships between things. We'll build up in complexity, but we don't want to complicate beyond that conceptual understanding. Because once you're done with this and you've played with things a bit, you'll have that level of understanding to attack almost any problem, right? As opposed to that point and click issue we talked about where you don't have as broad a range of abilities at that point. All right, so there we have bent them up, and they bent up along here, and you have very minimal control is what we're going to focus on here. If we are going to look at the separation between these internal faces, for instance, hit I for inspect, click on one face, inside there, orbit around your view, and click on the other one. And you'll see it's not 100, it's 105. If we go up to our cube and get a front view, we'll see that the bend is going out and up. So because we have a 2.5 millimeter thickness in our rule, it's adding 2.5 on that side. It's adding 2.5 on the other side for a total of 5 more on top of the 100. So if we needed these to be exactly 100 across because they're fitting something else, we'd have to make an adjustment in our sketch so that it comes out the way we intend. Now, that's one way, but there's another, maybe better way that I'm going to show by using an edge flange, which gives us more control over our things. So let us go ahead and do that. You can close that measure box. We don't need it. You can get a home view up here in your cube in the upper right. There's a little home icon when you hover there. And we are going to go ahead and name this first one a slow double click. We'll do it and just call this one bend. We won't get too crazy on the naming. I'm usually naming lots of things, but at least our components so we know when we look at things here. So there it all is. Now we want to make another one, another flange, and let's do it in its own component, but not inside the bend. We want to do it off the root. So go back up to the top level here and make it active. We can hide the bend, so turn off the eyeball there. We don't need, actually we need, take that back. We're gonna use that, we're gonna reuse that sketch. Let's hide the body only. So here's the body folder for the item. We're gonna reuse this sketch. So we need to see it. So we have come up here and made the root active, and we are going to make a new component. That was Shift C, enter. And this one, we are going to make a flange out of just the center for the start. So go ahead up and flange, click on the center one. And again, we need to flip the direction with the orientation from side 1 to side 2 and hit enter. There we go. We are now done with that sketch. So we can hide the bend. We don't care about that guy in the moment. All right. This is our active component. Inside it, we should see that we have made our face flange, right, from a closed profile right there. And now we're going to hit our flange again. And we're going to click on this top edge, the top edge there, and move across to the other end to the top edge. Make sure you don't get the bottom one. It can see through. Get the top edge. And now we get our little arrow. We can drag that up. And we see we now have our bends in some fashion. This field is active. Let's make it 25, I think I did. There it is at 25. And hit enter. Or no, we made them 50, didn't we? Let's go back and make that 50. We want that to coordinate. Down in our timeline, it's always adjustable, editable. We're going to edit this guy because we made 50 and I want to make a comparison. I double-clicked that icon in the timeline, and the value that we want for the height here is actually 50. Enter. There we go. All right, and save. I'll give you guys a moment to catch up. So right now we should have a face flange that we did an edge flange on each side, and they by default went up at the 90-degree angle, much like we did with our simple bend on a bend line. All right, let's take a look from the front. There we go. And let's now bring back the first one we did for comparison and turn on the body. So you can see if I turn it on and off, they're different. The new one is shorter from inside face to inside face, and the flange going upward is a different size, right? The one we just made is taller. as I go from one to the other. In fact, let's go ahead and make this one red. Hit A for appearance. A for appearance. Maybe we can search red. R-E-D. Maybe it's case sensitive. I don't see. Oh, 60 of them in here. Can I get it to show them? It says there's 60. There we go. Not red acrylic. Let's just do this first red. If it has this little download, it means you have to download it. They don't want to load everything up. But either one of these reds that is active, drag it over to your tree and drop it either on the component or on the body. And there it's gone red. And save, Control S. I'll give you a minute to catch up. The whole point there is so we can distinguish them. Actually, that brings me to something else. So we've done that. We do our save. Like that. We have saved. Another way I could have done that, as I think about it, is to color the components. Hit Shift N as in Nancy, Shift N. And you'll see how they're now colored automatically from some color palette. So that's Shift N as a toggle. If I do it again, I go back to the appearances that have been applied. They both got the same appearance, so I changed the one to red. But if you have a lot going on, it can be very quick just to go Shift N, and you also get to distinguish them. Cool. I'll go back to our fancy way there. The point here is the red is our original bend. And we didn't have much control over how that bend happened, right? The dialog box didn't have much in it. Whereas this other one, we have a lot more going on. So if we hide the bend and we now do that measurement again from the inside face to inside face, I for inspect. So this is our face flange and our edge flanges. And they're 100, which is what we want in this particular example. So let's cancel out of there, and we're going to go edit our settings. Let's go to a front view. It's going to be good. And by the way, to fit everything in, you can Alt or Option double click anywhere. That will automatically fit stuff in. That's nice. I'm going to zoom back out a little bit, but Alt or Option double click is a good one. All right, now we're going to edit this edge flange and see how that works a little more. So I'm going to go ahead and double click on that guy, and it comes up. You might have to do it a couple of times. It's finicky, but it's the quickest way. So if I've double clicked, here are the important things we're going to look at here. One is the height datum, and it says outer face. If I switch it to inner face, you'll see that it now goes taller. If I go back to inner, it goes shorter. Oops, did the wrong thing. Go back to here, go up to here, go into there. There we go. We're looking at the height here, right? That height datum reference, the height reference can be outer, inner, or tangent. And that's going to determine how tall it ends up. So if we needed the distance from the bottom face here to the top to be specific, we have to get this one right. The other control we have that we don't have with the simple bend here is our bend position. Right now it says outside, but if we go to inside, it now scooched in, which is probably in line. Nope, that's even different than this here. That went in way inside. But anyhow, this is where we get our control over how the bend happens. And there are other ones you can check into, but the one that works in our case for our design intent was the default, called outside. One other thing while we're in here, let's get a home view. I'm going to hover here and get my home. There are a couple things in here. We have, with each of these edges, by default it says full, but if you open it up, you can also have, for instance, symmetric. And when we do that, we get extra little gizmo control on the end down here, and we can actually pull this in. So it doesn't have to be the full length. It might not want to be depending on your design. And it also created a nice little relief cut area inside there. If you look carefully, there's been some geometry removed so that when you do the bend, well, in order for this to line up the way our bend position is, it has to have a little cut in there in order for that to work. The other thing that I will note in here is the override. Override the rule. If we click on that one, it's going to open up all of the areas of our rule. We have corner bend conditions, 3 or 2 faces meeting. We have the bend relief for the metal to deform in favorable ways. And then we have a bend override. For instance, that one is an angle. So if you have a special case, you can override the rule in that little area. Everything is good the way we had it, so let's hit cancel. I'm going to go home, and I'm going to save. So I do a lot of that action, getting back to my view. So that is all good. We are now going to move on to, I think, the case where, let me check here. So I have dimensions showing in the file that I'm going to share. We did measure, but I've made special sketches if necessary to give dimensions here. So we've done this one here, a simple bend. We did the face and edge flanges. And now we're going to look at a feature across the bend. We are going to be making, dun, 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 give you a little preview of where we're headed here. My system seems to be going a little slower than normal, but bear with me here. I'm going to isolate that guy and take a quick look at him. We are going to make this slot across this bend, but we have to flatten, we have to unfold it so that those cuts go perpendicular to the face of our sheet. Because when we take our laser cutter, plasma cutter, whatever we're going to do, we can only make a straight cut downward. So if we made our slot in this configuration, we would not have that situation. We'd have our cuts going at an angle because of this being mitered. So we're also going to look at this mitering here. All right, so that's what we're up to. That's where we're going. And here we go. We don't need either visibility on those other components. And this one here, I'm going to rename to edge, just so I keep track of things there, and make the top level component active because we're going to make a new component, and I'm going to save. So we're going to make a new component in the active top root level like that. So go ahead and do Shift C. We can name it in here if we want. We can say feature. So you can do it in the dialog as well, however you want to do it. You get to decide your workflows and at what time, how you're going to do things. Great, we are moving along here. So I am going to make another rectangle, R for rectangle, again on the ground plane. And again, we're going to come over to our palette and grab the center. And then here I'm going to wonder what's gotten a hold of my CPU cycles. It's gone really slow on my end. There's going to be 100, tab 100, enter. I missed it, so I'm going to alt double click out here. Oh, my keyboard is bouncing, by the way, so I got an extra 0 in there. Let me go ahead and edit that 1000 down to 100 and take a look. There we go. All right, so now we have our 100 by 100 over here, and that should be locked down. It's a simple rectangle tied to the center with 100 on each side. And now we're going to say finish the sketch, get a home view. We are going to do our face flange and then some edge flanges. and go from there. So go ahead and grab your flange tool, click on the top. Again, I'm going to make my side from side 1 to side 2 to go downward. And I'm going to hit enter. So at this point, we can hide the sketch. We don't need to see that sketch at this time. We're only interested in the edges. I'm going to do 3 edges around the back, so to speak. So go ahead and make our flange again. And I'm going to choose this front top and the back top and that other edge across top. And it gives us our little gizmo. And we can drag it up. So there we go. We did all that nicely. We now also get another gizmo for the angle. So drag that one to the left, and you're going to see, so it's flaring out, but it's changing the geometry so it always matches up in a mitered corner. If we don't have the miter on, that's here in our dialog on the right, miter corner by default. If we turn that off, it's just the rectangular side that it had extruded off. So click back to default, miter corners. That's what it means by the miter. So as far as that miter angle goes in the center here, mine snapped to 60. I'm going to make this 45 and maybe hit tab. Don't hit enter because enter will take you out of the dialog. So if you're changing values, you can enter a value and then it will update, or it will, you might have to hit tab. So now it's switched me to the distance, and let's go ahead and make that 25, doesn't matter too much here. There we go. So all of that is good. It has all of the same height, datum, bend position, etc. We're not going to worry about any of that, any of this. We're just going to hit enter. And we're going to save. So now we have to unfold this. So we have flat all the way across so that when we make our feature across the bend, it's going to work and conform to reality. So up here, we're in the metal context. Under the modify, the first one is unfold. So go ahead and click unfold. And it's going to ask us for a stationary face. Let's do this bottom inside face here. We could individually select bends, or if you check this one, go ahead and, if it's not already, unfold all bends. It automatically recognizes all valid bends, and then hit enter. And now when we look down into our timeline at the bottom left here and hover, we see it made the unfold feature. Furthermore, it started a group, that little plus button there. It's going to group these things that we do when we have it unfolded. We're in a special mode, by the way, and we know if we look on the upper right, there's a refold. So when you go into the unfold, you're in a special mode, and it's actually a somewhat simplified algorithm to unfold it. It's different than the flat pattern that we're going to see. But we'll get to that or go back to that. So the important part is we flattened it out. So let's make a sketch on this top face right here. So go ahead, create, and create sketch, and click on that top face. Now we want to reference this geometry here. So we're going to P for project. And probably a quick enough way is that one there, and then this one here, and hit enter. I would probably do it more economically if I was doing it for real, but for ease and quickness, we don't need to see the body anymore because we have them for reference. So there we go. And we don't need that first sketch. That was our rectangle square. There we go. So here's the bend, and here's where we want to go across. These two lines, by the way, click that one line, shift to add that one, click, and hit X on your keyboard, X-ray. And that has turned the line type into construction because we don't want it to get in the way of the slot feature we're going to put across here. So let's go up and make a slot. Say create. They have slots. we're going to choose the second one, overall slot, that. And so come up inside here somewhere and come down straight or otherwise, doesn't matter. And come down to here somewhere, click, and then move outward to give it some width and click. And there you go. You have just made a slot that crosses the bend. And we would constrain it normally, but we don't care because we're done with it for now in here. Finish the sketch. Bring back the body. We need to see that because we're going to do an extrude cut. And here our sketches folder needs to be on. And just this second sketch that has our slot. So give you a moment to get to there. The whole point is to have our body to cut and to have our profile to cut it with. Cool. We do E for extrude. We hover and find that profile. And then we get our little arrow, we drag it through. That works there. We can say distance all if we wanted to say all. That way, if we change the thickness, it's always going to find all the way through correctly and hit return or enter. And so now down our timeline, we did the unfold. We made the sketch with the slot. We did the extrude cut. And now we just need to refold. Click refold. And now we're back to where we're headed towards. So now in the timeline, it created a group with bookends. One is unfold. The other end is refold. And it has all the stuff inside it that we did. And we can hit the little plus minus here to expand or collapse, open or close that group. If I have that group closed, when I go back one step with my VCR controls, then we will be at the point where we don't have it. And if I go one step, it goes through multiple features in that group. And there we are. All right. Let's go ahead and save. Control S, enter. Are there any questions at this point? Am I going too fast, too slow? Any feedback?
Hey, I got
Now's
a
the
question
time.
actually.
Yeah, go for it.
Right before you drew the slot, you selected a sketch, like a surface. Could you repeat that little process so I
Yeah.
could see how you selected that plane to get all the lines to show up?
Yep. So that was a project, and we will go ahead and do that for you. There are multiple ways to project, so I'm going to go and edit that sketch. So I'm going to find it wherever, double click it there. So projecting is like a traditional movie projector, right? You have the screen, which is your sketch, and you have something outside of the sketch, outside of the screen. And when you shine the light through the frame of the film, it gets projected onto the screen, the projection screen. So that's what we're doing. And we can take entities from outside of the sketch, from the other sketches and or body entities. So that's what we're doing, a simple projection. So if I hit P for project, that is my hotkey. It's asking me here with the select button. If I hover, it should tell me eventually what it's looking for. No, hold up. Give me a moment. My system is doing weird things on me. Getting a lot of clicking. Oh, never mind. I'm back. So it's asking us to select something. And by default, it's an entity and not an entire body. We just want the entity. And so I get to select. And you see when I hover, it turns red. So it is finding that face on that unfolded body. And all of the edges of that face are going to come in. Or if I go to the right, I can choose just one edge right there. Or if I had sketch geometry outside of this sketch, I could hover and it would find that. Right. So if I come over, like I said, over here to this face here, I click and I hit enter. And if I hide the bodies so I can see it better, I just projected in that face, which was made of all of those edges. And they're purple, which indicates they are linked to the source, which means if the source changes, then it changes inside this sketch, which is generally the way you want it to maintain that relationship between the aspects of your design. And if I hover, by the way, I see a little icon. And that icon, if I do a long click and hold, it tells me that is the projected geometry. That is the link from the source into the destination sketch here. So I did that to have a reference. I mean, ultimately, I might want to dimension some separation between the slot and the edge. And then if I change the length of this edge flange, I'll always maintain that separation that I can define with my dimension. And I just wanted to make sure in this illustration case that I was spanning the bend, right? Because that's the whole point of this one, is to show how we make a feature that goes across a bend. And again, it has to be done when it's flat, so that when you actually cut the thing on your machine, this is what you're doing. You have a flat piece of material and you're cutting that slot through it, so that all of the cuts are going vertical and down through the material in the right way. So now if we say finish, and it's going to be outside of the, refold it and turn the body back on. And there you go. Now we have it. So hopefully that was enough to clarify that.
That was, yep.
Excellent. All right. So I'm going to step back to our previous model because we want to talk about flat pattern. And we're going to compare that to this one. As I noted, the algorithms are different. The purpose is different. And the simpler algorithm to do this, it may succeed and your flat pattern might fail. Now, the ultimate goal is the flat pattern typically, so that you can machine it with your CNC, whatever kind you have. So let's see how the flat pattern works. We are going to hide the visibility of our feature across the bend. And we're going to be back here looking at our edge flange here. Let's make it active.
Okay, can I just have a question?
Yep, go for it.
Okay, so regarding the extrude cut, I don't understand why the machine, why we have to do a totally perpendicular extrude cut instead of just extruding while the surface is, inclined.
Yes, good question. Because most CNC machines that are doing the sheet metal cutting, you'll typically have a plasma cutter, or you can have a laser, but they generally just have a vertical motion up and down.
Mhm.
They don't tilt. I mean, you could have one, but that's more advanced. Typically, you're just cutting straight down through the material.
So in this case, we should just, cut the metal as is instead of, unfolding.
No, because then it won't be in the right place and it won't make a flat pattern. You'll be violating the rules and the reality. Let me try and go back to here and show possibly in some fashion. So if I were, well, number one, if you try to make a slot cut from face on, you can't do it, right? You won't be able to cut this, right? So that's another problem. If you tried to make a slot, regardless of the angle of things, you won't be able to make the slot happen on this bottom face here. But if I just cut a hole, say I'm not going through, there's edge. Say I'm not going through, if I go to make a circle from the front plane, and I'm just going to make a circle, I'm not going to care about projecting or anything here. And I make my circle, and it's going to be a certain dimension. I'm important in my use case example here that this be 10 millimeter diameter, like that. So now if I get out of here, and I'm going to make, it's interesting that it is Could I just not see it very well? Give me a moment here. Where did my circle go?
I think you're in the wrong component. Yeah.
Yes, good. Thank you. I want to be in my edge. Yes, all that there. There we go. So I put it in the wrong place. Let me come here, and if I get, no, that's not going. I can use it. I'm going to just go with it's not. It's awkward. It's not optimal, but we can make it work. I am going to show that sketch, even though I don't want it in that place. Then I'm going to. So there's that one there, and then I am going to have this active because this is the one with the feature where I really want to see the body. All right, that's not optimal, but it'll show it right after. So there's the circle I made, and now I extrude, and I'm going to extrude through here. So we're not talking about across a bend, we're just talking about the angle problem in this case. And I'm going to say, okay, don't worry about all. So now when I go and flatten this thing, again, less than ideal, but I'm going to say unfold, I should be saying, and I'm going to do it here and there. And now when I come to the top here, see how my hole is?
Yes, yes.
I'm not going to get a circle of 10. I'm getting an ellipse, and it's not straight
Yes.
through either. Yep. So there you go. So
Uh,
that gives you a
okay.
better idea, yes, of why we have to do the unfold to go across, and not just across, but to make sure that the cuts are perpendicular to the face of our sheet metal. Cool. I am going to my undo list and go all the way till I undo. Where did I make? Edit, sketch, project, undo, show, hide, undo, finish, sketch, undo dimensions, undo circle, undo hide. Where did I make my circle? Undo finish sketch. Let me go there and see what happens there. Give me a moment to find out where I am here. Right there, undo that. I think I gotta go back one more. Go back one, go back another, undo sketch dimension. I got a delay on my system here. I'm trying to get back to where I was before. Why is it not going back? I did a bunch of stuff. There we go. Undo. Oh, that's when I did the project stuff, I think. All right, I think I'm back far enough. There and there. There we go. And we don't have our inadvertent sketch inside there. I think I am back. Let me get to the top here. Here, let me save. But that's okay. Ask questions anytime. The idea is for you guys to learn, so it's not just me talking. All right. I think we have what we need there. Collapse that one down. Hide this one. All right, we're back to where we were talking about flat pattern. And we're going to compare flat pattern to unfold, and then we'll see more stuff about flat pattern. Cool. So we have gotten back to this point, and I'm going to save. So make sure everybody is on the same page here now. We have just the component called edge showing there. I can go home there. All right. We are going to do a flat pattern, and that is here under create. And it is the very last item here, create flat pattern. And it's going to ask us for a stationary face. Let's choose this bottom face here and hit enter. And if all goes well, we get a valid flat pattern. That is to say the unfolded thing with the slightly different dimensions, so that when you bend it through the process of bending and how that shapes and deforms and resizes things, it turns out correct. So if our original sheet metal object is correct and follows the constraints of reality for constant thickness around the bends and all the other things it needs to have right, you will get a valid flat pattern. And we are in a special mode, and we know that because much like the sketch mode, we have a finish button up here. Looks a lot like it. So we're in a special mode where we have the thing flattened out. And if we look over in the left on the tree, we have a folder for bodies. And we have another folder inside there, a group for the bend lines. And that's for our center lines and our extent lines. So if we hide our actual body, you can see them a little better. They're kind of light colored. But there's a center line on that bend. There's a center line on that bend. And then there's the extent on either side here, whatever they call them, extent lines. And then back, bringing the whole thing back. So we have a number of things we can do with this once we have a flat pattern. We can export a DXF so that we can then bring it into some program to do our toolpath programming or whatever use we want for it. And we can do that with the export. So go ahead and click on the export. And then there's only one item in there. Click on that. And there's only one option in here that we'll talk about briefly. And it says convert splines to polylines. A spline is a fancy curve as opposed to an arc, which is a simple curve, if you will. A CNC machine only knows how to make a straight line or an arc. If you go into the G code, G0 and 1 are straight lines, G2 and 3 are arcs. That's all it knows how to do. Some older controllers and firmware and such are not happy with these fancy splines. So if you have to, you can convert them into many straight lines approximating the curve. So you segment or linearize the curve into poly lines, many lines. So you just have to know your machine or the service you're using, whether this is important or not. So you would say, okay, and then save the DXF off. Now, the person who's programming, they only want to cut the cut lines. They don't want to cut the bend line stuff, obviously. So whoever's programming it needs to pay attention, because when they use that DXF, there's going to be lines where they don't want to cut. So just take care when you get your DXF out. And the DXF itself is going to look like, in Illustrator, I have it open up here. And here are those layers that we saw, right? The bend extent, the bend profile, and the bend itself. So if I come in here and I select them all, you see they're color coded. I have them here in Illustrator, although you might open it in AutoCAD or eDrawings or some more CAD focused app. But Illustrator shows nicely. And if I open up one of these layers, by the way, here's a spline. Here's a line, spline, line, etc. So this particular DXF is made up of a lot of lines and splines. And then we also will notice, so there's the actual profile. So if I turn off the other two, so that's the only thing you really want to cut, right? That's the outside that you're cutting. These are reference. There's the reference lines. Those are the center. There we go. So those are the center references where you actually make the bend, and then that's where the bend ends up happening, the radius of the bend. So that is what part of your workflow, depending on how you're ultimately going to get your thing manufactured, you might need to get a DXF out of it. So hit cancel there. And with the file I'm sharing, you'll have the DXF and other stuff to go back and reference and learn from. So when we are done with that, we say finish. I have my little asterisk here, so I know I'm not up to date. I'm going to save right there. We're going to take a look at a little odd thing about this. If we go to our tree on the left and we open up our component for the edge flange, we see that it has created a pattern, flat pattern here. Now, to edit that flat pattern, you might think you double click or you right click or something, which is normal, but no, you simply activate it. So go ahead and click that activation bullseye, and now you're back into the flat pattern mode. So that one confuses a lot of people because it's counterintuitive and it's counter to the normal workflow in the program. And so now I say finish again. And I'm just making note again that that is where the flat pattern item is in that container component for the edge, and to edit it, you actually activate it. Now this thing may go out of date, or it may show invalid, and sometimes you need to update it, and sometimes it's just invalid because you're at some other point in the timeline, not at the final result. So when you get warnings and errors, you want to address them, but it doesn't always mean something is wrong in your workflow, right? It doesn't mean you've done anything wrong. It just is natural, and you're just not at a point where the flat pattern is valid, right? If I'm inside the unfold, then, and I try to go to the flat pattern, I won't be in a valid state. And so it'll show over here that a red that it's wrong, but it's not. Everything is good. All right, there we go, there we go, there we go. And then we'll talk about two other ways to use this. You can program on this right here in Fusion. And I'm going to show it in the other file because I've got it all set up. This one, you're basically just going to watch along here. So if I come into my manufacturer workspace, you will see that, there we go. In our model over here, any component that has a flat pattern, and by the way, you only get one sheet metal body per component. That's important. So any component that has a single sheet metal body and has a flat pattern for it is going to appear in this list in the model container here. So this one here does not have a flat pattern. I did not make a flat pattern for that one. That's the simple bend. But I did make flat patterns for these other ones. And the one that's active happens to be the edge flange that we've been looking at a moment ago when we made the flat pattern and looked at the DXF options. So I have made that one active here in the manufacturer workspace. And then I made a setup for it. And because it's a cutting operation, there's only one operation, that's our 2D profile. And then I went ahead and created a 2D profile right there. And you have your speeds and feeds. You have the geometry that you selected. I did silhouette from that list. You can choose silhouette, or you can just click on the face, and you see how it turns blue to show that that is the selected geometry. And then I could go and make a, I don't have it in here. I probably want to put that, an NC program. This tells me what post processor I'm using. This goes for a fire control controller for the Langmuir system. Uh-oh. Alec is bailing out. Okay, has something come up. So, but anyhow, this is where we do identify the post processor to get our machine control code, whether that be G code or otherwise. This particular processor, the extension is NC for numerical control. You tell it where to put it, you do some settings, and the second tab is where you tell it which operations you want to include in the program. And then when you say okay, you get a new folder for your NC programs. But being that this is not a manufacturing workspace CAM class, I just wanted to cover the basic overview and expose you. Now, number one, the fact that you can machine on your sheet metal object right here in Fusion. You don't have to get a DXF and send it out to a service, or use the DXF in here. It's integrated, fusing It's fusing, in this case, the CAD and the CAM. And the good news about this way, by the way, is if you make a change to the model in the CAD space, it gets reflected here in the CAM space. You just say update. Whereas if you're doing iteration and design changes and using an outside service, when you make those changes, you're going to have to output the DXF again and send it to the person, and they're going to have to reprogram on it. So that workflow is not as optimal as keeping everything in the one app in-house, doing it in this integrated fashion. So that's one of the main reasons that we want to know that this is possible. So there you have it. If we go back, the last thing that we can do with it is make a traditional drawing. And this one, I will show you some of the details of how we get here, because it's a little bit convoluted and not obvious. But ultimately, we are able to get a traditional 2D drawing, shop drawing, that we could send to a service and they could have it on the shop floor, or they could at least use it in some fashion for confirmation of, in addition to the 3D model that you might send them. So in here, we were able to identify the flat pattern and dimension it and create a bend table. And those are indicated in numbers 1 and 2. And here's the ID 1 and 2. And it tells us the direction, the angle, and the radius of the bends. So the operator, if it's more manual, they'll know how to do it in their press brake or whatever. Or if it's numerical control, then you at least have some indication of what's supposed to happen. There is also the possibility to give a view of it folded up. But note that this is not a 3D model. This is a projection onto this flat plane here. So if you try to dimension off this, they won't be valid dimensions. So this is only for visual. That's the point. It's not a 3D model. There's no 3D data representation there. If I try to make a dimension from the inside to the inside, it won't say 100 like we made it. So that's a caveat to take care of that. So let's see how this is done, because it's a little bit odd, counterintuitive. The first thing we have to do is be in the flat pattern mode. So remember, we come over here to the tree, we find our flat pattern, and we go to the activate button. And now we are in the flattened state, which is what we want to make our drawing from. So on the Mac, I come up here. On the Windows, you'll find out, how to get into your file section, I hope. So we get to our file section. We have new drawing, and I'm going to say from design. From animation lets you do exploded view, by the way. And so now this is coming up with some default template of the size of the sheet based on an ISO and etc. So I'm just going to say accept that. And that takes a little moment to set all of that up. The screen goes black for a moment, but it's okay. It's just doing its thing, figuring it out. And then once we get into here, what's going to happen? Taking a little longer than I would expect. Hopefully it's doing it. Maybe I have to click and wake it up. Well, that's not a good sign. I don't think it should take that long. Oh, there you go, just a matter of time. Okay, so now it's asking me to place my base view right there. So I'm going to just go ahead and place it somewhere here. And I'm going to hit enter and accept all of that. And now I could make a D for dimension. And I could go from end to end, for instance. There we go. There's a dimension any way you want to and need to. Then as far as the table goes, it's up here under the table drop down. You can identify the bends and you can make a table, but I think the table does it for you, hopefully. The table, if the table goes on the top, the title bar is on the top. on the bottom. The title bar is on the bottom, and you can't change it afterwards. So for the moment, I'm going to put it on the top. So it automatically identified the bends 1 and 2. And now I can bring this, oops, now I can bring this down if I want to. There we go. So now I have my bend table, and it's calling out and automatically identified these. You can do a lot more with how this gets displayed and whatnot, but this one you don't have any editing at this time, unfortunately. You get what you get when you make it. And lastly, in here, we will look at the ISO kind of view, our 3D view, and we're going to make another base object. So we say create base view, and then here, the problem now is we have a bunch of other stuff showing, and that's a front view. I don't want a front view. I want a view that I made. Maybe there's an isometric view. That one might work. But you see all of the other flat patterns are in there. We're going to want to change that. And then I want to go to solid over here, shaded. And the representation is the model, not the flat pattern. And I'm going to click it there. I can actually change the ratio here if I want, make it a little bigger. There we go. Now I'm going to click. And then say OK. But I have all the other stuff in there. That is because by default, unless you've done something else, all of the models show up. So we need to hide or disable, more accurately, that, and disable that. And boom, now we have just the one we're after. So the workflow is a little convoluted. It's a little less than optimal, but it works. And once you understand it, you're good to go. So we now have successfully created a traditional 2D drawing with our title block, with our flat pattern dimensioned, with a bend table, with the bends identified with numbers here, and then a base view of the folded final product. And lastly, I guess, you're going to want to share this with somebody, perhaps, and you can go ahead and export the sheet as a DXF or the other output options. And with any license other than the personal, you get multiple sheets, but there's the sheet that we just made. Or you can make more sheets if you need to, but only if you have a license other than the free personal license. So here we go. We have made this. When you save the file, the main file, this sheet, this 2D drawing can be saved with it if you choose so. And then when you open up the main file, it goes along for the ride and you can access it again. So for instance, if we come over to our table data panel here, and we look at the big file I made here and open it up, and then here is a section that tells me, are there any drawings associated with it? And in fact, there is one there, and I could open it if I had to, which is how I got that other one open. So again, and this is a little tricky, the fact that your drawing may or may not be saved with your design, and that it's going to ask you, so you have to pay attention and follow along to get it the way that you want it. So there we have that. So the 3 ways that you could use, or 3 possible ways you could use your sheet metal model, is to flat pattern and output a DXF that could then be used by you or somebody else in some other program to do the toolpath programming, for instance. You can make a traditional 2D drawing and output that for use as a DXF or otherwise. Or perhaps ultimately, if you're set up nicely, you can just do everything right in Fusion and go from the design workspace to the manufacturer workspace, and then do your toolpath programming there. So lots of options, all good stuff. So let me come back to here. Where were we? Untitled. And get out of the flat pattern. There we go. And I think if I look to see where we go next in our sheet here, one over to the right there, we just did edge and stuff here. So we're next going to look at contour, lofted, and finally a special case. Contour is very simple. Lofted is a special case, but is nice. And the last one is quite involved, but I want to at least expose you to it. So let's get back to our Fusion. Where did you hide? There we go. Back to Fusion. And I am going to, I'm at the top level here. I've got edge feature. Why am I not seeing everything? I haven't done it yet. Okay. We are now at the end of time down here on our timeline. And we're seeing everything because we're at the top active level right there. And we are going to make a new component. We're still in the sheet metal. We're at the top. We're going to hide that guy and save before I do my next major action. All right. I give everybody a moment to get up to the same place. We should be looking at previous things turned off. And we're at the top level, root level active. And we're going to shift C. And I'm going to hit tab to go up to the name. And this is going to be contour, C-O-N-T-O-U-R. And this is just a simple curve or line. So I'm going to go ahead and create a line, L for line. I'm going to choose the front face this time, the front plane, like that. And you can make any simple straight line thing. I have a sort of M looking thing, but it doesn't really matter for what we're doing here. Maybe I'll make a little different than the other file. There we go. Hit enter. So there is the thing that we're going to do a contour flange, which is just a simple extrude, but it's not a closed profile. It's open. So we say finish. And we make our flange. So this flange is kind of intelligent. Depending on which thing we choose, it decides what kind of flange to do. So I'm going to go ahead and do that. It made a chain selection by default, all of them in a chain. And then I can just move it back. And we have some of our stuff here again, right? Our direction, our orientation, our overrides, whatever we get there, we hit enter. And then there you have it. So that's about the simplest. So if you have to make an initial face flange and then bend angle, bend angle, bend angle, it might be difficult to do those angles in a logical, easy, editable way. Whereas in the sketch, you could define your dimensions, angles, and lengths and such. So this will be more convenient in certain cases. So there you have it. So that is all there was to that one. That was quick and easy. Let me go ahead and save, which brings us to the lofted flange, which is fancy and nice. So I'm going to hide that guy. And I am going to make a new component from the root level. Always remember, of course, to know which is active. Right there. Control C, enter. Going to make a square, and then up high we're going to make a circle. So R for rectangle. Do it on the ground plane. Come back over like we did before to the palette and choose the center one. Come here, come out. Maybe we'll do another 100 by 100, 100 tab, 100. Oh, I got 1,000. Tab back, 100. I think we're good that time. All right, we are done with that. We made our first shape. Let's make an offset plane so we can do our circle up higher. So there is an icon, should be one there for offset plane. You can do it from the sketch or from the ground plane. Typically, the ground plane is probably better. And then this one can go up however high. Maybe it goes up 100. Like that. Alt double click, Option double click. There it is. Let's get a top view. We're going to make our circle on that plane. This geometry is just like any other geometry. You can actually manipulate it. So for the sake of illustration, I know I'm going to put a circle somewhere in the center of things here. That plane is the shape according to whatever you've chosen to offset from, and it's not always appropriate or, the way you want it. So let's now make C for circle, and we're going to click on this here. Let's get an angle and make sure that we're not choosing the wrong thing. That right there. Make a circle in there. And that circle can go from the center out. Instead of 100, maybe we make it 75. What does that look like? Yeah, 75 looks good. Hit enter, finish the sketch. So now we have our two shapes closed profiles that we're going to loft from one to the other. Now, if we just did a standard loft, it'd all be curved and it would all be one piece, and that's not what you want. You'd have to do a lot of extra work. So the good news is our lofted flange is our friend. So let's save before we go to our next move. I save often. We're going to click on the flange, but we're going to look first into the dialog on the right here, and the second type is our lofted flange. So we're going to click on that. So we're going to go from this bottom one to this top one and take a look. So right here, we have the side that it goes from, the forming type. The first one default is a break form. This one is a die. If we click die, it's going to be smooth arcs, so that material has to get bent in one nice smooth piece. The default, which we're going to use here, is a break form, and it's faceted in some fashion. That would be doable in a solid model, but there'll be a lot more work. So we are going to keep that one. Then the facet control is either by a chord tolerance, a face angle, a face distance, or we're going to choose the last one, the number of facets. And so right now it's 5. Let's make it simpler, down to 3. And now you see we only have 3 facets instead of 5. And we hit enter.
Okay, Swami, I have just another question.
Yep.
So on the facet numbers, does it have any effect on what can actually be done, in real application?
No, I don't think, to my knowledge, I don't think there's any problem here. You just decide how accurately you want to approximate that curve. It's like when I said on a spline, if you approximate a curve with a bunch of straight line segments, in order to get closer and closer to the original curve, you need more smaller and smaller straight lines. So this number here is sort of an approximation. And let's see, we're gonna go to 10, see if it'll process it in a decent time.
Okay.
There you go. I think that's the only consequence of it. So we're back to 3. Now, if we try to unfold or flat pattern this, as you might imagine, it's not going to work. It's all one continuous loop, right? It can't. Something's got to give. We got to cut a line somewhere, a slit, a gap, an opening, so that we can unfold it or flat pattern it. There are a couple ways to do that, and they each have their pros and cons. I'll show first the simplest one, but it's not quite as dynamic when you change the model. No, it's called RIP, and we're going to go up under modify, and it's right down here called RIP. So go ahead and find the one called RIP, and at various times you can read the tool tip, but we're to go to RIP, and now we haven't used it, for instance, so I don't know what I'm supposed to do, so I let the system tell me. Select a face, an internal edge, or a start point on external edge. I'm going to go here, and it's going to highlight. It found a little point right there where they meet. And then I'm going to come down to this bottom here. I'm finding this bottom edge. And when I get to the midpoint, it happens to recognize that and show it green or somewhere else along that. So I'm going to go to the midpoint and click there. And boom, it has made a relatively wide gap of 10 millimeters. In reality, you need to make that smaller, like 1 millimeter, so your bead, when you weld it together, is going to go there. But for visualization, 10 is good. Have this little effector here. This is not finding the midpoint dynamically. It did a calculation as an offset. If we look in our dialog on the right here, it says offset 47. So from some reference point over here, the midway point is 47. So if I drag this here, you see now it's at an angle. So the downside with this approach, can I drag it and find the midpoint again? I'm not sure if that's finding the midpoint. Once I've dragged it one time, can I get back to the midpoint? I don't think it's recognizing the midpoint because it doesn't really know the midpoint. It just knows that offset distance. And that is the crux of the downside of this. It's quick and easy, but if I were to change these profiles or this geometry in some way that it's not all lined up nice and symmetric or in this particular way, then that line might not be straight down the way I really wanted it. So in order to deal with that, you have to make a sketch and reference the line, project in the line, find the actual midpoint and the value and use that value. So that is a little bit convoluted, but I will show what that is in here just so it might make a little more sense. If I come in here and show my lofted guy here, and I go into my lofted here, into my sketches here, I have a line projected from the flange base for the rip offset. So I have made a special extra step, special sketch right here. And I projected in that edge that it referenced. And that value is driven, and I named it rip edge referenced. And then I use half that value to know that I'm at the midpoint. So that's a little bit involved. It works. Requires a little understanding, a little math to make it work. So plan B, which I will show in the finished form and not go through the time and effort, but just to show you how this works. If I bring this back and I go to here and I look at my groups here, not that one. I think it goes back to here. Yeah, that's the one. If I unsuppress this one, this has been suppressed, not calculated. Now you see I did the same result on the back face there, but I created a special sketch with that line right there going through from the front there. So I made a special line straight through here, which is where I want my rip, want my cut. Extended it a little bit, so I make sure I cut everything from the top to the bottom because the angles, you might not get it entirely right. And then inside here, I do an extrude cut. So rather than using the rip feature, I'm going to come into here. Uh-oh, what just happened? Why did it not do that? Click there once and wait, and double click that one. Give it a moment to get to the feature edit. Maybe I right click it and do it explicitly that way. There we go. Double click usually works, but it's finicky. So right there, I did an extrude called fin extrude, by the way, which does not require a closed profile, just a open one, like a line. So I identified that line as my selected profile. And then I said, go ahead and extrude it all the way through. Extent type all from the center and go out in one direction, go out in the other direction, and make it a 10 millimeter cut. I have a parameter for it right there called rip gap size 10 millimeters. That little FX will turn on the value of your parameter. So the whole point here is, no matter what the case is, if you have a lofted flange or you have a shape that's a continuous loop, you can't unfold it or flat pattern it. You have to cut a slot. You have to rip it, as they say. And they have a rip feature, but it has the downside that we noted. It's going to move around in certain cases when you change the geometry. Like if you're prototyping or something, you're not exactly sure what the final geometry is going to look like. So in order to deal with that, depending on how things change, you might be able to get away with it better by making a line, then extruding it through, and then you're going to get the split that you need to make your flat pattern. So there we have it. I'm going to cancel out of there and come back over to, I don't think it's that one actually. I think it's this other one. Yeah, that was the drawing. Let me go back one. Here we go. There we go. Go to a, okay. So now we are ready to make our flat pattern. We have our lofted flange from one closed profile to another, only two. You can't do more than two like you can on a solid body, just two here. And here it is over here. And this one is loft. Go ahead and name that one if you'd like. And we are going to create our flat pattern. Maybe I choose the back face right there. Hit enter, and if all goes well, we get a valid flat pattern. There you go. So your cone comes out like two circles. If you made this all smooth, two circles with a common center to make a cone. So well, it's got flat bottom, so it's not like a normal cone. Close to a cone. So anyhow, that is our flat pattern for that fancy piece of geometry. And then again, we have our export if we need to get it out as a DXF for whatever use after here. All right. I think, and we have to close this out, finish the flat pattern. I think the last one we have, if you have the time and the energy, I'm going to keep going with it. And we're going to be posting this, sharing it anyhow. So I'm going to go through the whole shebang. So let us now look at the last order of business. We go to the end of time. This one you'll just watch along. I haven't shared this or anything at this time. I'm going to hide stuff and bring this back. I think I have some named views for this here. This is our special case. And what's special about it? This corner right here is problematic and would be difficult to model in the sheet metal mode and have it dynamic, easy to understand, easy to edit, because this corner cut, a contrived model though, is currently defined by the midpoint here along that edge, that goes to the midpoint. This one goes to the midpoint here, and this one goes the same distance that it took to get to the midpoint down here. It goes from the corner of our cube over to there. So I've defined it just by those distances, no angles. The important part is no angles. So if I tried to make, like we did before, a face flange on the bottom and then make my edges coming off the four sides, then when it comes time to do this one, I'd have to go 90 degrees here, 90 degrees here. But what is this angle? It's a result of this other stuff. So I could use some math, some trigonometry, maybe some constructed geometry and dimensions and parameters, but that would be a mess. It would be very difficult to know that angle and to have any control over these distances in my design intent. So this particular geometry doesn't lend itself well to the standard sheet metal mode. You will see that there are all those cuts, and then all of the silver highlighted ones are where the bends are. So if you just think of a simple cube without that little corner, the base is on the ground, the four sides fold out, and one of those sides has to have an extra to account for the top of the cube. So hopefully that gives you a basic idea of the geometry. We're going to go into a little further and it should become more clear. So let us go into our timeline and find where we need to go back to. This is getting some dings on someplace. This is special case corner relief. We don't want to worry about that right now. This next group is special case requiring 3D solid first. There we go. So that is the group we want to get into. I'm going to go back one and I'm going to open this big group up. If I hover, you see all of those features. So there's a whole bunch of stuff going on inside this one group. And let's see what is going on inside there. I'm going to go ahead and step through. So I make the component, and then I go and make a sketch. So here is going to be my bulk form. I'm just going to make a rectangle, extrude it. And then once I do that, where's my body? Show my body. There we go. So I go ahead, I extrude that simple square up there. Then I make another sketch, which is the one that is giving me the fancy corner. Right there, you can see it right there. That's the one I was talking about. And it's a 3D sketch so that I can recognize things that are off plane. But that's what I was saying. I recognize the midpoint here, the midpoint on that edge, and then that distance is the same distance here as it was to the midpoint there. So again, that would be very difficult to manage in the sheet metal mode. So we're first making it as a solid model, and then we will ultimately convert it into a sheet metal model. And if we have observed all of reality, it will successfully flat pattern. So I'm going to go ahead and snip that little corner off there. So now if we look at it, we have our little corner cut off. So hopefully that gives a little better sense of the geometry we're working with. Now I'm going to go ahead and make some things that aren't showing. Let me see if there's a problem with this. I'm making some fillets. I should see some fillets. Let me rebuild my timeline. They aren't getting computed. There we go. By the way, I hit Command or Control B as in boy or build, Command Control B, and that will recompute recalculate the whole timeline. So something I did going back and forth, when I got to this point in time, it did not properly compute that fillet feature. So for illustration, I have them color coded. So the red is where I need to cut. Because right now I just have a solid block with the corner cut off, right? It is, in fact, if I give here a section view and I go inside, we see I have a solid body. So it's not hollow. There's no skin. It's not sheet metal, anything yet. It's just one bulk solid body. All right. So we have to identify, there's more work in this special case. We have to identify the edges that we want to cut, which I have shown in red. All of the vertical edges need to get cut, right? Because we're going to unfold it with the bottom base on the ground. So we have to cut all the vertical edges. And then we have to cut along this top edge, that top edge, as well as this top edge, but not that back edge. So by cutting off all the verticals and across here, this flap folds out, that flap folds out, that one folds out, this one folds out, but also contains the top, which we will see in a moment. And I did that in this fillet, and I get to choose how wide. That radius on the red cut has to be the sheet metal thickness in order for it to match reality and properly flat pattern. So if I go, I have them in parameters. The point being, this red one here, this arc, this fillet radius has to be the same as the thickness of my sheet metal. These green ones, or no, this one, I take that back, I correct myself. The green are the bends. The green bends have to be the same as the sheet thickness. The red can be whatever. Within reason, the red can be, I have to have them the same as the sheet metal thickness for ease and for illustration. So the whole point here is we've made our special geometry as a solid body. We've identified edges that need to be cut, and then the other edges are the ones that need to be bent. And we're going to go about removing the surfaces here. So I'm going to do that next. Boom. So now you see I have cut away, and it's not a solid anymore. In fact, if I look here in the tree, we can go before and after. If I go back one in time, that icon is showing me that it is a solid body, right? It's a white cuboid. Now, when I go forward one in time and I just delete one face, when I'm in the surface context, by the way. So you go into the surface context and you identify your faces. And when you delete them, it converts it from a 3D solid body to a 3D surface body, indicated by that orange cylinder with a slit in it, orange matching the context color in the toolbar up here. So that's important. We're good. Had something on the side. I'm back. So we're getting somewhere. Now we ultimately need to thicken this, right? Because it needs to be the thickness of our sheet metal, ultimately. But we need to make a stand-in sheet metal component that we're going to join it to. So I'm going to use this back face and come out here to the left outward and make a sheet metal face flange here. So go ahead and do that in the next step. I project it in the geometry to get that face. So that one is now been created here in our tree. And you see the icon. That new green one is in fact a proper sheet metal object. Because we're going to turn this surface into a solid by thickening it, but then we need to join it, combine it with this other one finally to make it one final sheet metal body in the full shape we need. So let's go ahead and do that. We go forward one, and this is our thicken. Boom. So that surface went outward all the way on the outside. It went outward, and now it's the 2.5 millimeters thick based on our rule for our sheet metal. And because I've done it correctly, that green one is perfectly where it needs to be on that face. And it's the perfect size because I projected in the geometry right there. So everything is the way we need it. We just need to get this solid body here, right? If I get rid of all this other stuff, there's the solid body we're after in order to unfold it, to flat pattern it. But it is not a sheet metal body at this point because we made it as a solid body as we needed to because of the complexity of our design intent and the form. So the magic is going to be to combine it with an actual sheet metal, and it will turn everything into sheet metal. So I'm going to go ahead and do that here. Boom. Now we see in our bodies folder, we're left with what we want, just one body, and it's the proper sheet metal body. And that was our combine over here. So that step right there is our combine join. And we don't keep the original. That's the default anyhow. So we said, combine our sheet metal object and bring this other one to it. So the first one is the one that remains. The second one are the ones that get consumed, that get joined to it by whatever operation you choose. And we chose the default of join. So again, the important thing here is before we did our join, our final geometry we wanted was not the proper type. It was a 3D solid body, but we want it to be a sheet metal body. And that's what this last operation does right there. And now this lets us do our unfold. So I open that up and I say unfold. And then I get there. And again, this is the problem area up here because we've defined things by the distances and not by an angle. And even if you had to do it at an angle, it might be difficult to do. The 90-degree angles are simple. It's when you have something different, not 90 and based on other things. So it doesn't just extend this. It's not just this corner bent, right? If you just bent this corner, you don't have enough material to cover the gap, cover the hole you made in that corner. So that's why this thing comes out looking like it does. So now we have a thing. Now you see that these come together perfectly like this. Let me see if I have. Yeah, that is coming together like that and like that. If we go and change that value, this is where I said I had parameters for everything. So for the cut, instead of the cut matching the thickness here, maybe I make it just 1 millimeter. So now my cuts aren't as wide. And that little internal where they meet, where you have your bend relief come together, now it's not perfectly meeting with the same size cut and the same size bend. Now you get some other weird geometry in here. And this is where you're doing your bend relief. So when you're doing the bend and you're deforming the material, it's going to stretch and compress in certain ways. And if you don't make a certain geometry in here, it won't do it well. Won't do it the way you want it to do. And so if we go back and undo to where we were, we can make what's called a round. And that round is that circle right there. We could cut around here, and determining the size of that circle and where it goes is something that the sheet metal mode does for you automatically. But because we've done this special way, you have to do more manual work and figure it out. So I have put a circle here in a good location to get the end result that we're after. So now I do my extrude cut in the unfolded way. Has to do it when it's unfolded. And so now when I refold, you see I have that round in that corner where I have three faces, three edge flanges coming together. And that, by the way, is covered. This is the most advanced part. If you follow me this far, you're doing well. Here is my infographic, and here are here's what we're talking about at this particular time. When I made those cuts and bends the same size, I'm gonna move my zoom out of the way here. The same size, I got this perfect pair, right? They met perfectly here in the corner. That was the first case. Then this is not the second case. The second case is closer to this, but this is just a square cut in that corner for bend relief, corner relief. And then this one here is the one that I just showed you with the circle. But all of this happens in the flattened, unfolded mode so that our cuts go through perpendicular like we discussed. And the final geometry comes out this interesting looking curved thing here. But it's really, the source of it is a circle. So if we go back to Fusion, we see the actual 3D thing right here. There you go. Gives a little better sense of what we've done there. And then we make a flat pattern and we do all the flat pattern stuff we need to do with it. But the point is that that is a lot more work. It's doable. And they might make a case in the future where it's supported more automatically or semi-automatically like these other things we did. Like the lofted one didn't exist initially. When they made the sheet metal, you had to do the loft thing all manually. And it was a lot more work, but you could get there. So this special case is similar. It's a lot more work, but you can get there. But maybe in the future they create, in fact, I've submitted this. This is not my original idea, by the way, but I have submitted this to the tech support and they are passing it on to the dev team. So there's at least a possibility that this type workflow could be simplified by being made semi-automatic by incorporating it into the sheet metal features. So that is how all of that one works. If I collapse all of these here, there, collapse that there, bring on, we're about wrapping it up here, trying to get everything back nice to talk about here. There we go, look at that. So let us see with pride all that we have done here. So we have been through all of those specifics. We went through all these activities with a face flange, a simple bend, an edge flange, flat patterns, DXF output, unfolding, refolding, features across bends, contour flange, lofted flange, special case, drawing, cam, etc. So quite thorough. Now, of course, you're going to have to do the hard, put in the hard work and time and effort and going back over this stuff and getting into Fusion. Again, I will be sending you the file to play with, the full file that I'm showing here in the graphic with all of those cases that we investigated. And I'll be sending you links to all of that and other helpful links and information. So it's not rocket science, but there are a lot of things to consider, a lot of actions, a lot of tools to explore and understand. But it's all doable. So I don't expect you to understand everything. I don't expect you to remember everything. I expect you to be confused in certain areas, and that's all normal. That's all part of the process. But the hope is once you do put in the time and effort and whatnot and put the puzzle together and understand everything, then you will be in a very good position to realize your ideas, which is the ultimate goal, I think. And with that, I think that's it. I might have missed something, but that's more than enough. So this is Q&A time. You guys get to spit out any feedback and questions and whatnot.
Not Q&A really. I missed a bit in the section. There's certainly a lot of information to digest.
Yep.
Thought it was very good.
Excellent.
I will go through the video to pick up what I missed, but yes, a lot of ground covered. Thank you very much.
You're welcome. I am aware that I can overwhelm. I have a broad and deep knowledge base and experience, and I have an Energizer Bunny focus. So, but that's why the main thing is to be exposed to these things, be aware of them, and then have the material that you can go back over and actually learn it. Right? You're not going to learn sheet metal in all the range that I have taught today.
Not in one session.
Not at all. But you have the tools, you have the right mindset, you have the right understanding of how it works. You had exposure to the tools and the various geometries and the requirements, and all the important stuff has been laid out. And so I have confidence that if you put in that effort, you will get to where you need to get to. Yeah, so that is that. All right. Anything else from anybody else who's left? We got a couple. We got, I think, just the two of you are here at the end. Oh, and by the way,
go ahead.
Oh yeah. Wait for the video that I post. So I have been recording this. I'm recording this. It's getting stored in the cloud, and then the Zoom app goes to processing to create a transcript, and the transcript has timestamps on the side of the screen. It's also going to make chapters with highlights, which are also linkable. And then it's going to make a summary of the entire thing, which I have to go in and edit some. But to get the most of your efforts going back over it, you can use the video that you saved, but the one that I end up posting is going to be more valuable, just so you know. All right, Islam, go for it.
So first, thank you for all of this. It's been really, opening my eyes to. I'm actually new to sheet metal, so I learned a lot in just one session.
Yep.
Thank you, and I hope if you can make other, parts for this in the future. That would be very interesting.
Yeah, we will consider things moving forward. So when you have questions, just hit me up in the Facebook PM. I am a retired bum without a job, so this is what I'm doing with my time. So I'm fairly available and open to helping people. I am a teacher by nature and profession, so this is just what I do. So again, both of you, everybody, put in the hard work and effort and struggle and confusion and get moving forward. One thing I will note, since you mentioned you're being new to sheet metal, modeling it is just one thing. The actual fabrication and having the experience and understanding what can and can't be done in the real world and how sheet metal fabrication and stuff really works, that's a whole nother thing. I have touched on those things to the extent that was necessary in the class here, but we have been focusing on the actual implementation within Fusion of the sheet metal features. So it's a big subject is what I'm saying.